At the end of the 18th century, machines were already powerful. They could cut iron, shape brass, and move entire ships across the oceans. But they all shared a fatal weakness. Not a single screw truly matched another. Every machine was unique. Every repair was guesswork. And industry was trapped by human hands. Until one mechanic asked a dangerous question: what if machines could remember? To understand this revolution, we need to go back even further in time. London, 1770, a city of smoke and ambition. In the workshops along the Thames, the air smelled of hot metal and whale oil. Men sweated over workbenches, files scraped against steel, and hammers echoed in irregular rhythms. Each craftsman was a small universe of knowledge. Secrets passed from master to apprentice. Techniques guarded like family treasures. Before precision, there was skill. And skill meant hands. Every screw was cut by eye. Every thread was slightly different. Nothing was interchangeable. If a part broke, the entire machine stopped. Industry didn't scale. It survived one craftsman at a time. A screw made in Manchester wouldn't fit a machine in Birmingham. A part made on Monday didn't match the part made on Friday. Even the same craftsman, on the same day, produced variations. The human eye can discern differences of half a millimeter, but machines need tolerances of hundredths, even thousandths. This gap was the abyss that separated craft from industry. The British naval arsenals faced a devastating problem. Warships took years to build, and each cost a fortune. But when they needed repairs at sea, far from England, the spare parts didn't fit. Screws wouldn't thread. Valves wouldn't seal. Men died not from a lack of parts, but because the right parts existed only in the original workshop, in the mind of the craftsman who had made them. Henry Maudslay was not a gentleman inventor. He wasn't trained in theory. He was a working mechanic. Born in 1771, the son of a carpenter at the Woolwich Naval Dockyards. At 12, he was already filling powder cartridges. At 15, he worked in the forges. By 18, his hands knew metal better than most men know their own families. And every day, broken machines reminded him of the same truth. Power meant nothing without accuracy. Maudslay didn't hate machines. He hated inconsistency. Two screws that should fit didn't. Repairs took hours. Assemblies failed. The problem wasn't strength. It was memory. Machines forgot what they had done just moments before. In 1797, Maudslay was working for Joseph Bramah, who had invented a lock considered impossible to pick. But there was a problem. Each lock was made by hand, each one slightly different. If a key was lost, the entire lock had to be replaced. Bramah dreamed of interchangeable locks, but his craftsmen said it was impossible. The human hand had limits. That's when the realization came to Maudslay. The problem was never the screw itself. It was the lack of a standard. Without a reference, there could be no repetition, and without repetition, there could be no industry. Think about what this meant. For thousands of years, humanity had manufactured things: swords, clocks, carriages, cathedrals, but each object was an original, a negotiation between intention and possibility, between what the craftsman imagined and what his hands could produce. Maudslay's leap was to realize something profound. Human hands would never be enough, not because they were weak, but because they were inconsistent. Even the most skilled craftsman had bad days, got tired. His vision failed under poor light. His mind wandered. What Maudslay imagined sounded impossible. A machine that could guide itself. A tool that advanced at a fixed, remembered rate. A machine that could repeat a human decision perfectly every time. His solution was deceptively simple. A lead screw, a threaded shaft connected directly to the movement of the cutting tool. Each rotation advanced the tool by an exact distance. The machine no longer guessed, it remembered. But building this required something that didn't yet exist. To make a precise lead screw, you need a precise lathe. To make a precise lathe, you need a precise lead screw. It was a paradox, a vicious circle. Maudslay spent months refining. He made a lead screw, used it to make a better one, and used that to make an even better one. Each iteration approached perfection. Each generation of machine taught the next. By 1800, he had succeeded. For the first time in history, a machine could repeat a thought. Not strength, not speed. Thought. The implications were staggering. Screws became interchangeable. Parts became replaceable. Machines became reproducible. Imagine this. A worker in Liverpool could manufacture one part, and another worker hundreds of miles away in Edinburgh could make another. And when they came together, they would fit perfectly. No adjustment, no filing, no guesswork. This wasn't just an improvement, it was a total transformation. It was the difference between alchemy and chemistry, between astrology and astronomy. It was the shift from trial and error to pure science. This revolution was sparked by a man named Henry Maudslay. In 1810, he opened his own workshop, and it became an unofficial school for the brightest minds of the mechanical age. Joseph Whitworth, Richard Roberts, James Naismith Hall, these giants of engineering passed through Maudslay's doors. Each one would take the concept of precision and push it even further. Whitworth developed the thread standards that we still use today. Naismith invented the mighty steam hammer. Roberts created machines that could make other machines. All of them started in that one workshop, learning the same fundamental lesson. Precision is not a luxury. It is the very foundation of modern industry. Think about what this made possible. Locomotives with interchangeable parts that could be repaired anywhere. Steamships with standardized valves, making global travel more reliable. Textile factories filled with identical spindles, churning out fabric at an unprecedented rate. Even military rifles, where every single component could be replaced right there on the battlefield. The Industrial Revolution wasn't just powered by steam, it was powered by repeatability. And that repeatability was born in the workshop of a mechanic who simply refused to accept inconsistency. Without Maudslay's insight, our world would look completely different. There would be no mass production, no engines built at scale, no aviation, no modern engineering as we know it, no computers, no smartphones. In fact, every single manufactured object you touch today owes its existence to a man who, in a way, taught machines to remember. Precision wasn't invented out of thin air. It was taught. Henry Maudslay never saw himself as a revolutionary. He was a problem solver, a man who hated waste and inefficiency, who just believed that things could be done better. He passed away in 1831, relatively unknown outside of engineering circles. He received no grand titles or royal honors, just a modest fortune and an impeccable reputation among those who understood the true value of his work. But his legacy is all around us. Every machine that operates with perfect consistency, every automated factory, every assembly line producing millions of identical parts, they all echo his original idea. It all traces back to that one moment when a mechanic decided that machines could be more accurate and more reliable than human hands. But this was only the beginning. Maudslay wasn't alone in this quest for perfection. Others would take the concept of precision even further, often creating things that were far beyond what their own time could fully comprehend. The story of precision was just getting started, and its consequences would continue to reshape our world in ways no one could have ever imagined. Thanks for watching. If you found this story as fascinating as I did, be sure to like and subscribe for more deep dives into the hidden histories that built our modern world. See you in the next one.